Hi there, I'm the Duke, and this is the series in which I'm streaming. I'm a computer programmer. I'm a front-end developer. That is, and I'm trying to learn a lot of different and new skills and technologies. So I'm just streaming what I'm doing and what I'm learning. First things first, I have a couple of things to mention. This is my new wallpaper. For some reason, I really like this strong pinkish and bluish hues, the street light lamps, and this aesthetic. It's really pretty. It's my friend actually saw this wallpaper and he says it's tiring to his eyes, but to me it's nice. It's appealing. It's visually great. I also have if you are watching me, you also know that I'm using my tablet as well. So my tablet also has a new wallpaper. Liminal spaces. All right. So before I continue, I just wanted to mention something, and that is the fact that I'm doing things slow, and I don't want to do things slow. So basically, I'm gonna try to now go through the sections and through everything that I'm learning a bit faster, right? A bit faster. So that's it. I'm not gonna bother you anymore. Let's go. So what we did, yeah, I'm starting with C. I want to finish this project before I do anything new. Uh, it's not exactly something that I don't say I don't want to say appreciate. Just it's a bit boring as of late. So let's try to wrap this up. Um, okay. So what we did is we are following. I'm actually following a book by a really great programmer named Daniel Holden. The book is called Build Your Own Lisp, and I'm trying to build my own Lisp accordingly with some not a lot, but with some of my own innovations. This chapter now is about conditionals, so about comparisons between different statements and branching of tasks and logic. So let's do this. So what I did already is I think I defined some new built-in functions for the comparison methods, such as greater than, less than, equal to, and all the other comparison operators. I didn't do this the last time. Now is the fact that I'm trying to define an if function that will test for some conditional, and also we are going to evaluate some code based on the logic of the function. Let me just find the methods that I already created. Built in here. What? Oh, just a second. I just realized my stream is private. Okay, I think now it's gonna be okay. Okay, so what I did here is the following. I have created already some of these built-in comparison methods. We have greater than, less than, greater equal, and less than equal. So all of these are the new comparison methods. So what actually are we using here is we are using our list value data type, which is a structure that we are using as the basis for all of our types in the language that we are writing. So here we define the method, then we are calling the built-in order, which will be this is just basically an abstraction, an encapsulation of the real logic which will be found inside built-in order. Okay. So these are our ordering functions, and they will only work on numbers, and we only want them to work on 2 arguments. Okay, so these are the wrappers. Now here is the real logic. We checked for error condition first, and then we compared the numbers in each of the arguments to get the results that we want. Now, let's talk about equality. Equality will be, and this is the equality method for comparing 2 list value structures in our language that we are writing. Equality is gonna be a bit different, a bit complex. So because here we only compared number types, but equality should work and should work on a lot of other types. We want not only to compare numbers, we should also want to compare equality between different types of list values, evals, or compare against empty lists, or even compare 2 functions between each other. Okay, I don't think that there's a good way to write. Okay, here is a question in programming language design. When implementing equality functions, what is something to keep in mind? When implementing equality function in a programming language, here are some considerations to keep in mind. Equality semantics, decide the type of equality the function should check. Yeah, this is actually what I mentioned. So we can either check against reference, where we check whether 2 objects or values are actually the same instance in memory, or between value if they have the same properties inside. Also, we have precision and tolerance for floating point numbers. We can also handle different types, data structures, and okay, these are all actually ensure that equality is symmetric. If A equals B, then B should be equal to A. I mean, this makes sense. Should also be reflexive and transitive. We should also handle null or undefined values. Nice. So let's without further ado, let's code this. First snippet here checks whether the types are different. If X type is not equal to Y type, we are going to return 0. So immediately we are canceling the equation and failing it, actually returning not equal. Now, numbers are just compared. Symbols are just compared, but they are compared because they are string behind strings array of characters behind the scenes. So we need to compare their string values, errors as well. Now, here we stopped the last time. Let's talk about functions here. All right. So let's talk about functions. How can we compare functions? How can we compare functions? If the x has a built-in, or if the epsilon Lisp value has a built-in. In this case, I should just return the built-in compared like this. Otherwise, so what is the built-in method? The built-in method is one that is created with the environment on running the application initially. So these are not user-defined. These are defined here. I mean, they are defined by the user. They are written by the developer, but there should be instantiated once. They should be built in actually in the programming language. But where are they? I remember. Here they are. These are all the built-in methods. So they're actually checking whether these are equal. Okay, if they are not, now what should happen if they are not equal? What should happen if they are not equal is the following. We should make sure that the formal argument and that the bodies are equal. In the end, these are just lists of characters, and list of characters are represented by Lisp values in our implementation of the language. So that's this. That's that. Okay, now how can we compare Q expressions and S expressions? So how could I do this. Now this is a thought experiment. I have the solution, but I would like to think about it. So I should iterate through the Q expression or the S expression and compare every individual element in it. So oh god. I just finished my workday and let me just remove this. So I just finished my workday and my brain is stuck on TypeScript mode. Int. But I can do another thing here. I can check if x count is equal. It's not equal to epsilon count. In this case, what am I doing, man? In this case, 5, 3, 4. In this case, return 0. Right? Makes sense. If they have different number of elements here, if they have different number of elements here, yeah, they shouldn't be able to do this. So otherwise, if L will equal x cell at I index and epsilon cell at the I index, but I shouldn't check whether they are equal. I should check whether they are not equal. What have I done? What am I doing, man? What am I doing wrong? Here? What am I? Is this okay. If they are not equal, return a 0. So that should be it. Otherwise, return 1. I should also break the switch statement. What is this one? What? No, this one shouldn't end this. It should end this array. And this, yeah, should end the big guy. Like this. Oh, it seems like I have an extra. I think now it's okay. Okay, this should be fine. Now. Now. Look at this. We need to add. Equal and not equal. And I can do this by leveraging some of these methods that we have written. So I need to make sure, okay, let's not think about what do I need to do. I need to compare, let's say, two what do I need to do here? I need to leverage this method. Basically, I need to use, what have I done here? Why is this small? Move it to 20, not 21, 20. So I need to leverage this method. And next, when I write, I don't know, expression 1 equal wait, how is written? It's written like this. Expression 2. I should hit this. Okay, let me think about it. Let me think about it. Elwell, built-in compare. What am I taking? I'm taking the environment. I'm taking the Lisp value. I'm taking the character for comparison. Make sure we have two elements. I have here somewhere the Lassert count. I can jank it. Have I janked it? I hope I did. Count. Wait, what is this method called? Here. Paste it. Nice. I'm just gonna change the string here. We are gonna use the operator from the arguments. So what will I do here? Let's create a response flag if string compare, if the operator is equal to double equals, and if it's this operator. So what am I gonna do? L will be L equals a, the first element in A, and the second element in A Otherwise 556. If string compare if the operator is not equal, this. Let's delete this guy and let's return the number. EA. This. Otherwise, it's not equal. I'm just gonna do the same thing, but I'm gonna use the not equal operator. Okay. Let me just think about this one more time. Okay, sorry, I wasn't thinking about the project as much. I found my old mechanic keyboard here and I want to connect it to see how it runs. Let's see, hopefully I don't need to install anything. Okay, I see some lights. Okay, I forgot I need to unlock it, but how do I unlock it? No. No. How is it working? Okay, let me just check if I messed up my stream. Hopefully I didn't. Just a second. If I keep on speaking. Okay, it works. Why isn't the keyboard working? So how is it called? It's a basic. It's an old white shark. Let me see. It's a white shark. White shark keyboard. How to use? What's the name of it? GK20 GK2022. Okay. So function. Oops. So function and down. No. Function and down. Okay, now the keys are still not working. Okay. It's gonna take some using two, but I think I should be right. So we have our operators, we have our comparison operators here, but at the same time we're gonna need an if function, and this function, if you already know what it does in other programming languages, upon some condition being true or false, it evaluates one thing or the other thing. So let's do this. Okay. Maybe. Where's this character? I already forgot. Where's this character? Where's this Asterix? I don't believe this. I basically forgot where. Ah, here it is. LL. Built-in if. Length. E. A. So let's create the if operator here. So we created the function, but now let's create some assertions. So this guy should have 3 children, right? It should take the elements to compare with, and the comparison the comparison symbol. Next thing, let's make sure the type is correct. First element and the type of the first element should be a number. type of the second should be a co-expression. Type third one should also be co-expression. So what should I do now? I should create a new Lisp value. So the two guys that are being compared against, the type of them should be a next expression. Let me just copy this guy, paste it here. So if the conditions of a comparison are true, we are gonna evaluate the first expression. Otherwise, let's evaluate the second one. Lastly, let's delete this and let's return the X. Now we should just be able to. What have I done? I didn't want to do this. How can I search? I need to do this, and then I can do add built-in. Oh, I made a mistake the whole time. I was using regular Vim instead of NowVim. I like NowVim because it lets me search with style like this. Nah, no. Then add here. Here's where I want to be. My boy, here's where I want to be. Here, can I paste this? I think I need to open the visual and then I can paste it. Yes, So in Vim, how to indent multiple lines of code. Let's see. So I can use like this or like this. Let's maybe 742 all the way up to 746. Let me just take another look, sorry. So it's 742, 746, and then I have this. Okay, nice. Let's see. So what happened now is I registered all of these methods, and hopefully now, let's split this. Functions. Yeah, I think this is it. I should just be able to write the functions to conditionals. Okay, how many errors will I have? Oh god. Good. Built-in add. Okay. 11. Let's see what's happening here. 470. Okay, I think I know what's happening here. How can I copy this whole line? And then I need to see where I did my forward declarations at. All the way. 55. And it's here. So paste. No. What have I done? Paste. Ah. You must be kidding me. What have I done? This wasn't here, right? I don't think this was here. I'm gonna remove it. And I'm gonna search for lvol. Oh no. Built-in order. And then I'm gonna copy this line. This is the line that I want. 1, 2. Then I'm gonna go 58. 58. And here I should paste it. Remove. Move to the end. Remove this character. Now, how can I remove only one character in Vim? I know how to remove a whole line. But how to remove only one? Ah, the X. Okay. Let's save this. Okay, how am I switching between the tabs? Ah, with the tab. Okay. Let's try to do this again. 483. 483. Oops. So first thing, this guy is incorrect. This should be like this, because this is less than equal. Yes, let's save this. Let me check if anything has changed. I'm not very confident it isn't. I need this. Save, build again. Expect what? 491 int return. This shouldn't be a return. This should be only the R. This should be only the R. It built. Oops. Conditionals. Let's test. 10 greater than 5. So it's 10 greater than 5. This less equal 8850 is 5 and 6 equal is 5 and an empty q expression equal 1 and 1 is equal. It's not equal and yeah. Now is this equal? 1 2 3 5 6 1 2 3 5 6. No, it's like 5 6. X epsilon 100 200. It's an empty method if x and epsilon are equal. It's epsilon, otherwise minus x epsilon. Amazing. Now we have conditionals here. Now we have conditionals. What have I done? No, I just wanted to remove the search from Neowin because it's stuck. How can I clear it? How do I clear the Neowin search? Starting with all my everything that I searched for is selected. Oh, so it's okay. So it's the command to clear the search highlights in Neovim. We are using NOH, and by pressing enter, it should clear everything. So okay, let us just now mention recursive functions, which, first of all, we created conditionals and we actually made our language a lot more powerful. because by default, they're gonna let us implement recursive functions. And those are the types that call themselves. The only thing that we need to add is termination case. Let me just do this, yeah. So recursive functions. And this is something that works. Let me just remove this. What is this? So I should have fun. Len all if L is equal to an empty object, I should return 0. Otherwise, I should return the last element. Oh, this is so ugly. And it doesn't work. Why? Symbol not found. Fun. Do I have the symbol fun here? Fun? Ah, I think this is I think I know what the problem here is. Fun. I think there is a built-in method that I didn't implement myself that actually creates functions a lot more easier than using the full syntax. It's like a syntactic sugar for this variant that we are building, but I'm just checking to see where it is. Wait. Actually, do I just need to define it? No, it doesn't work like this. It works like this. I define it here, and now this works. So basically, what happens here is the following. This is some method that's first been defined using this synthetic sugar-like string. So this is the method in which we are implementing a function called len. And this function tells us the number of items in a list. If the list is empty, we return 0. Otherwise, we return the length of the tail of the input list plus 1. So we are repeatedly using the len function until it reaches the empty list, and then it returns 0, and then we add all the other results together. Okay, so we have a base case. Then we take a chunk of it We put this chunk aside, we come all the way to the base case, and then we come back up. Nice. I like this. I like this. I really like this. So this is done. Today's episode. Let me just save it. Ah. There's one other thing that I wanted to do, and that is the following. Just a second. I can close this, I think. How can I close this? Control Shift V. Okay. This, I don't think I also need this. Let me just take a minute to get some water and to refresh myself, and I'm continuing. And I'm back. So what I wanted to do now is to start learning. I have a book also on deep learning, so in Python. So I will try to just a second. Okay. I'm gonna try to start learning. Well, I have no idea what deep learning is. I read about it in university, but I have no idea what it is, how it works, what's important, and stuff like that. So basically, this is gonna be a blind learning session. But before I start, I want to do something else. I want to do something else. Do I want something else? No, I don't want to do anything else. So let's start. I'm so nervous. Okay, is this working? No, it's not. Why? Why is this not working? Mm-hmm. Wait, why is this not working? Oh, sorry, just a second. Okay, it works. So. Deep learning in Python. Okay. Okay. Again, I'm a complete noob. I have no idea about this. So this will be my first introduction to these concepts. Okay. It says here, oh, I can turn this off. I don't need this anymore, right? And I can move this to the center. and increase its size. Like this. And once I start coding again, I'll take it off for a lower size or whatever. But for now, I think I'm alright. So first of all, deep learning itself. Deep learning. What does it mean? So we have deep learning, we have deep neural networks. We need to train them. How is all of this interconnected? I have no idea. So we also have most probably some NN architectures, also natural language processing. Yeah, I'm just writing down the concepts that I have no idea what they mean or what they do. Yeah. Okay, sorry, one thing before I continue. I just realized something, and one thing before I continue is the following. I already did this. Thank you. But I want to do something else, and this something else is to do remove the navigation bar. Remove the navigation bar from the shared screen. Is this even doable? Is this even doable? Do I have... How can I remove or hide the navigation bar in Linux Ubuntu? The window navigation bar in Linux Ubuntu. In Ubuntu, there are a few ways to hide or remove the window title bar, navigation bar. Is this it? I think it is. Window title bar. Ubuntu. Yeah, this is the one. Or is it? For specific applications or globally. Okay, so I have GNOME tweaks. Go to window title bars. I have GNOME tweaks, I think. GNOME tweaks. It's here. So go to Windows title bars. Title bar buttons. Where are you? Extensions. Where is it? Or use the extensions tab. Where is the extensions tab here? Use some window manager extension for GNOME for specific applications, which hides the type of bar temporarily. So wait, F11. If I do this, and if I press F11, no, it doesn't work. It doesn't work, my man. It doesn't work like this. So my best idea to do this is probably using the tweak tools, but oh shit, I hit my elbow. GNOME tweaks, go to it. or use the extensions tab. But how? Okay, with GNOME Tweaks, how to temporary hide the window title bar on Ubuntu Windows. Let's see if Google. How to remove the title bar? Yes, this is what I want. I have one Ubuntu 2004 GNOME desktop and I want it to be fully black and ideal. As reference, I have thank you. Okay. Unite. 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 Okay. Try the Unite extension. All right. Sorry for the for the discretion here. Let's continue. Let's continue. Can I open this guy again? Yeah, I can. But he's not centered anymore. Now he is. Okay. Okay. So these are some of the concepts of deep learning. Things that I have no idea what they are, what they mean, or anything. So we also have GANs, which are generative adversarial networks, or a GAN. No idea what this means. So it says here, what this book covers. Okay. Okay. So. Let's start. Let's start. I'm learning machine learning. So I'm learning machine learning. So on one side, we have concepts such as ML, and on the other side, we also have concepts such as AI, and we also have concepts such as big data. And both of these are not are not the same to uh, machine learning. By the way, if someone is watching this, keep in mind I'm also just starting learning about deep learning, so I'm as clueless as anyone. I might have some more experience considering that I have been working as a developer for the last 7-8 years, but these concepts will be as foreign to me as anything. So yeah, this was just a note before I start, in case someone thinks I'm an expert or something, which I'm not, but I might become one. Haha. Let me just do this so this fits better. On the screen, I think it's okay. I have no idea. It doesn't bother me much that that isn't centered. Okay, so big data. Big data is a term used to describe huge datasets that are created as the result of large increases in data that's gathered and stored. Okay, so I assume this is just data that's collected either from the social networks that we are all part of, internet forums, cameras, maybe even data that your doctor collects. You know, who knows? Who knows if they are selling these information to anyone? So it says here, it's estimated that Google alone processes over 20 petabytes of information per day. 20 but how big is 20 petabytes, man? 20 petabytes. Petabytes. A petabyte. 2050. How, oh sorry, let me just hide this for now. How big is 20 petabytes? 20 petabytes is a massive amount of data. To put it into perspective in bytes, 20 petabytes is equal to 20,000 terabytes or 20 million gigabytes. 20 petabytes could store around 6.8 billion hours of HD video. If you watch these non-stop, it will take you over 770 years to watch everything. If a typical high quality photo is around 5 megabytes, 20 petabytes could store approximately. Wow. Wow. And this is the amount of data that Google goes through in a day. It processes it in a day. Wow. IBM estimated that every day 2.5 quintillion bytes of data is created, and that 90% of all the data in the world has been created in the last 2 years. Okay. It's a huge amount of data. So what are we using? We are using ML techniques in order to make sense of the data of those very large data sets. So ML is the tool used for large scale data processing. So it manipulates and analyzes complex data sets that have huge amount of data, of variables and features. And they work best when they are performed on large data sets. Okay. And machine learning can also be predictive in a sense. And they could be adapted successfully to artificial intelligence systems. Machine learning can be thought of as the brain of AI systems. And AI is a system that can interact with its environment. Okay. It seems like a fairly simple definition. What is AI in simple terms? I'm basically asking an AI what an AI is. I'm asking him to define itself. It's a technology that enables machines to perform tasks that usually require human intelligence. These tasks include things like understanding language. Blah, 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 blah. AI is like giving a computer the ability to think and learn. I like how this is how ChatGPT has put this in quotes, as he thinks he can lie to me. Oh, sorry. The whole time I'm yeah. ChatGPT, you old fox you. Okay. So machine learning is the brain for the machine which analyzes data received through its sensors or environment in order to get an appropriate answer. Okay. So we have Siri, which is an example of it. Siri hears the command and outputs an answer. We also now have ChatGPT, which gets data and it outputs data back to us. Okay. Now, let's divide this. So we can divide machine learning techniques. We can divide them into supervised, into unsupervised, and into reinforced learning. Okay. Now, what's supervised learning? So what's supervised learning? Okay. They use actually already labeled data. So they can classify similar but unlabeled data into labeled data. And I mean, a simple example of this is the spam functionality in your email clients, in which if a user receives a lot of junk emails, a supervised machine learning will analyze these junk emails and then use them as training data, and it can classify all of your emails like spam or not spam, and for each sample the machine will try to predict whether the email is a spam or not. And if it makes a mistake, it will adjust its parameters in such a way that the next time it encounters a sample, it will classify it correctly. And if it gets correctly, then the parameters will stay the same. Okay. So for spam, we only have two classes. We have either true or false for whether it's spam or not. We could also train an algorithm to see what root it is. Okay. Or something similar. Basically, we have labeled data, we know what something is, and then we input new data, and and the learning algorithm should analyze this data and label it correctly according to the labels we already have. Okay. One way to think of supervised learning is to imagine we are building a function defined over a dataset, which comprises information organized by features. In the case of female classification, the features can be specific. I'm reading this from a book. The features can be specific words that may appear more frequently than others in spy emails. Okay, if someone uses sex-related words, that should classify someone as sorry, I just read the comment from Jose Spinoza. Where does data science get into mix? I have no idea. That's why I'm learning this shit. Okay. Each email will then have an associated set of features, and each feature will have a value. In this case, how many times a specific word is present in the email body. The machine learning algorithm will then seek to map those values to discrete range that represent a set of classes or a real value. I have no idea what this means. I have no idea that the authors have nicely provided us with a function, but me being a smooth brain, I have no idea what this means. Well, but let me do this. Let me hide this. I am reading a book on deep learning, and I can't understand the sentence above. Can you simplify it? The machine learning algorithm will then seek to map those values to a discrete range that represent a set of classes or a real value in the case of regression. So we have some input data, and we should link this input data to some specific outcomes. All right, to some specific outcomes. If the task is classification, like sorting emails into spam or not spam, it will match the data to a fixed set of categories, right? If the task is regression, like predicting house price, it will match the data to a continuous value. Okay. I think I'm grasping it. Okay, one example of supervised learning is the classification of digits that are handwritten. So we have a set of images that represent 0 to 9, and the machine learning algorithm will try to classify each image in one of the 10 classes. where each class corresponds to one of the 10 digits. Each image is 28 by 28 pixels inside, and each pixel is a feature, and the algorithm will use a 784 dimensional feature space to classify the digits. So it is 28 by 28, so it's what's 4. And this is what, 16, and the 6, 22, and here I have, why am I doing this? Here I have 6, and this is 4, and this is 5, 4, 7, 4, 8, 7. So we'll have 784 pixels in size, and if each pixel is one feature, then the algorithm will use a 784 dimensional feature space to classify the digits. Wow. Okay, let's create a new one. So now, these are some of the most popular classical supervised algorithms. So what do we have? We have linear and logistic regression. And I think the focus is on the word regression because regression algorithms are a type of supervised algorithm that uses features of the input data to predict a value, such as the cost of a house. If we have other certain features such as size, age, number of bathrooms, number of floors, and location. Okay. I think I remember this from university. Basically, we get, and I think we even worked on something similar. I think we got like a homework to do that was doing something similar to this, to regression algorithms. We get some data and we have some regression features, and then based on these features we try to analyze and find the value based on these parameters. So in a linear regression algorithm, the goal is to minimize a cost function. Okay, we have something called a cost function. What's this? No idea. By finding appropriate parameters for the function over the input data that best approximates the target values. Okay, so this is an error function. Error function. The cost function basically says how cost function basically says how close we are, or how far away from we are from getting the correct result. A popular cost function is the mean square error. So mean square error. Okay, I don't like theory, so we're just gonna try to do this as fast as possible so I can start coding. Where we take say we have a 100 square meter house and it was built 25 years ago and it has 3 bathrooms and 2 floors. And the city is divided into 10 different neighborhoods, which will denote with integers from 1 to 10. And say this house is located in the area denoted by 7. And we can create parameters for this house by writing 100, which is the size of the house, 25, which is the age, 3 bedrooms, 2 floors, area 7. and this house has a certain price. This. And we want to create a function that will, based on these parameters, find the final solution of f of x, which is 100,000 euros. So what we need to follow, okay, now the math comes here. I need to find a vector of weights. V1, V2, V3, V4, and V5, such as the dot product of two vectors. Like, first of all, a couple of questions. What is a dot product of vectors? The dot product of two vectors is a way to multiply them together to get a single number, a scalar, not a new vector. Is calculated by multiplying each pair of corresponding components of the vectors and then adding those products together. Okay, so I have A. So I have two vectors A and B in 3D space. I have this is the way they are represented as, and the dot product is calculated as this, and the dot product even has a summation formula. Okay, the dot product is useful because it tells us if two vectors are perpendicular. If the dot product is 0, it's related to the angle between vectors. How would a dot product tell us if two vectors are perpendicular? Like, I love math, but at one point I just came to the point in which I couldn't understand the explanations and proofs, so I dropped it. But I would like really to understand how it works, and the dot product can tell us if two vectors are perpendicular at a 19 angle to each other because of how the dot product. Okay, when we compute the dot product of two vectors A and B, the result is but again, how A and B are the length of the vectors, and this is the angle between the vectors. If A and B are perpendicular, then this is 90. Yeah, the cosinus of 90 is 0. Okay, what are magnitudes? I'm a smooth brain, yeah. I already said this. The magnitude of a vector is essentially its length or size. For a vector, it tells you how long or strong that vector is without considering its size. So first of all, I have no idea how to think about vectors. Like, what is a vector? How in my mind's eye, where I model shit that I'm learning based on other shit that I already know before. How can I model a vector? You know what a vector is. The magnitude of a vector is essentially its length or size. For a vector, it tells you how long or strong that vector is without considering its direction. If you have a vector A with these components in 3D space, the magnitude or length A is calculated as this. For a vector in n-dimensional space. But how? Give me an example of a vector and calculate its magnitude. Also, how can I think of vectors in my mind to make it easier for me to understand and remember them? Suppose we have a vector with components. So this is a 2D vector, meaning it lies on a flat plane and points in a certain direction. To find its magnitude A, we use this formula. So what is this? Are these just points in space? So this vector is just a point, or represent both the direction. From the origin. Okay. Bam. I'm an idiot. I'm a smooth brain. I'm gonna change my cover on. I'm gonna change my cover. So let's do the vectors again. We have a vector A with components. These components. And this is a 2D vector, meaning it lies on a flat plane and points in a certain direction. To find its magnitude A, we use this formula. So we plug in values, and I get 5. So the magnitude of a vector is 5. So the vectors are arrows. The direction of the arrow shows where the vector is pointing, while the length of the arrow represents how strong or long it is. But wait, I'm such an idiot. I'm such an idiot. Wait. This makes sense. Because if this is space, the flat space, x and epsilon, and if I have 0, 1, 2, 3, 0, 1, 2, 3, 4, and this is the point. This is the point, so I have 3 here and 4 here. It's basically Pythagoras theorem, right? This is just the, how do you call it? It's the hypotenusis? How to say it? Pythagoras. Hypotenuse. How do you say hypotenuse? Hypotenuse. How do you pronounce it?
Hypotenuse.
Hypotenuse. Okay, so it's just the hypotenuse, right? Examples. If you think of forces, so this is also a force. Oops. If you think of vectors as moving from point A to point B, the direction shows you the path to take, and the magnitude tells you how far or strong the movement is. Okay. let's continue. So where did I stop? Yeah. So I have these vectors with this amount of data that I wanted to find a vector of weight. And if I had 1,000 houses, we could repeat the same process for every house. And ideally, we would like to find a single vector that can predict the correct value that's close enough for every house. The most common way to train a linear regression model can be seen in the following pseudocode block. So I can initialize the vector v randomly, and then I set up the cost function to 0, and then for every sample target pair, xi, pi, I have no idea. Again, so here it says we iterate over the training data to compute the cost function. Once we know the value of the cost function, we'll use the gradient descent algorithm to update v. To do this, oh, there are so many things that I hear the first time in my life. So let's start this. The pseudocode outlines the steps to train a linear regression model using gradient descent. It's the gradient descent using the. Let's break it down step by step. Okay, I think I'm also done here with this one. Sorry. Oops, sorry. Okay, so initialize the weights. So this is a vector. V is a vector of weights that represents the parameters of your linear regression model. V is a vector of weights. So these are the parameters of your linear regression model. Start by setting V to random values. These weights will be adjusted during training to minimize the error. Okay. Vector of weights. The training process will repeat until the MSI falls below a specific threshold, indicate that the model has learned well enough. So E is the sum of the cost of the errors for each sample in the training set, which will be calculated in each iteration of the loop. Okay, calculate the error for each sample in the training set. So for each input target pair, so this is the input feature of the ith sample, and this is the actual target value for the ith sample, which here is the actual price of the house. In this step, you add square. Okay, first of all, I have a couple of questions here. I have a couple of questions. First one, what is a vector of weights? Can you give me an example? Why do we set it to random values? The second question, the training will repeat until the MSA What is the MSA? Okay, I understood that the cost function is 0, so it's the error that it's the value that represent how close are we to the correct value. So I think I understand this. What do you mean by the input feature and the actual target value? Can you give me another example? In this step, you add the squared error or cost between the predicted value and the actual target TI to E. Okay, I hope I understand now. So let me try to write this. In the context of a linear regression model, a weight is a parameter that tells us how much each input feature contributes to the final. Ah, okay. I think I understand this. I think I understand now. So basically, the weight I remember now from my university, the weight uh, is a value that tells us how much a certain feature is important to the final evaluation. For example, what is important if we are selling a house is if it's in a good neighborhood. Probably this weight of a good neighborhood will be the most important one, or one of the most important. Another one is, for example, the number of rooms, because houses that have more rooms are of course more expensive than the ones with less rooms. So, oh, and some not so important weight is I don't know, if when was the last time the house got painted. I mean, it's important, you know. Some people would like to move to a freshly painted house, but it's not the most critical thing. So the weight for this uh, input feature is pretty low compared to the others. When we talk about a vector of weights, we mean a collection of these weights. Okay, we want to predict a price of the house based on two features. We have size. Okay, let's try to do this. Let's say I'm trying to sell a house and I have size and the bedroom number. And we can represent our house like this. Size, bedroom number. So what we have is X. Let's say the size is 1500 and the bedroom number is 3. So our weight vector V would have two weights. It would have the V for the size and the V for the bedrooms. And with these weights, they are gonna tell us how much a number of bedrooms influence the price of the house. Right. To begin training, we set these weights to random values. Ah, yeah, that's why we set them to random values, because we haven't yet learned what the values work best. And as we train, we adjust these weights so the model learns the optimal values that minimize the error in our prediction. And now, what is MSI? Mean squared error. Mean squared error. So what's this? It's a metric used to measure how well our model's predictions match the actual values in our training data. For each training example, we calculate the difference between the predicted value and the actual value. So, okay, so if the house that has the size 1500 and has 3 bedrooms is worth 100,000 euros. So next time when we try to find a house that is like this, we are predicting based on something, and we are predicting based on those weights that we will define for this. And the formula that actually is the formula that is the best metric to measure how well our model's prediction match the actual values is this MSI. So how does it work? So it's MSI. It's MSI. It's 1/n. I starts from 1, goes to the n. Prediction I minus actual I squared. So why? Okay, so let's do this. So we have this guy again, 1500 and 3, and our weight vector is 210,000. So we can predict the price by using a linear equation in which I'm gonna multiply 200 by 1500 and add 10,000 by 3. So it's like what, 300,000 plus 30,000, 330,000. So let's say the actual price is 300,000. And so I do 330,000 minus 300,000, and it's 300,000 squared. This should be squared. And then I have what, 9 million? How many zeros do I have here? 1, 2, 3, 4. How many zeros should I have? 8? 1, 2, 3, 4, probably 8. 4, 5, 6, 7, 8. So if we had multiple houses, we'd sum up all the errors and divide by the number of samples to get the MSI. So, and divide by the numbers of samples. But wait, this is 9 million. What? How big is this number? Okay. You know what? I'm really sorry. I'm gonna stop here. Wow, I've been going at it for 2 hours, so I'm just gonna stop here and I'm gonna continue. I'm really interested in how this works. It's really interesting to me, but I'm gonna continue another time. So thank you all for watching this, and I hope to see you the next time. Yeah, I just wanted to mention I have 92 subscribers now, so everyone watching, thank you. And I don't know, in the end, I'm just learning stuff, and if someone finds this interesting, because I don't know, I see a lot of experts here and a lot of people that just do things, and I felt, compared to those people at least, quite I don't know, I felt like I wasn't good enough, like I wasn't up to some standards. And later I found out that most people have issues learning new things, and most people have trouble, grasping new concepts, even really smart people. And I don't know if this help. First of all, I don't consider myself smart at all, but if this helps you in any way, because I'm learning and maybe you can learn with me, you know, I that's one of the reasons I'm doing this. So